Okay, what we're looking at here is it's called a Genicon. That's a brand name. What it is a little handheld generator. So when I drew the diagram of the generator in the lesson, I didn't draw it very well because I just wanted to get the physics across to you. I only drew like a single piece of wire. But in reality, we know that the more wire you have in the magnetic field, the more electrons will be influenced and the greater the potential difference will be that you generate. So in reality, that loop of wire is repeated. It goes around and around and around and around, and sometimes there are hundreds and perhaps even thousands of loops of wire that are all engineered together to rotate the same way through the magnetic field. And that's what's going on inside of this. There's a little generator inside. You can see it's the silver component inside. There are also a series of gears, and when I turn this, those gears take the coils of wire that are inside of that little generator and cause them to move very fast. If I want to generate a potential difference, then I can connect the output of this generator to something which can carry a current, and when I crank it, I get electrical energy out. Now, I'm getting electrical energy out of 2 light bulbs. I've wired these 3 light bulbs together the same way that things are wired together in your house. And things are wired together in your house so that you can turn some things off and still get others to operate. So I can turn on any number of bulbs I want here. One thing you notice is that if I have more bulbs going, it's harder. Well, you can't really notice this, but you might be able to tell from the sound. It's more difficult to get them to light up. I have to work a lot harder. Okay, one more thing I'd like to show you quickly here. The Genicon is being used as a generator in all of these demonstrations, but I told you a few minutes ago in the lesson that there's really not any difference in terms of how these things are built between how a generator is built and how a motor is built. Now, right now what we've been doing is we've been supplying mechanical energy as an input by cranking the handle, and the output has been electrical energy. But if that's how it works as a generator, I ought to be able to reverse the process and take a power supply and connect the power supply to the Genicon. And then I'm going to plug in the power supply. And you can see that what happens at this point is the Genicon is acting like a motor. It's an electric motor. And in fact, that's what's inside of it. If I want to cause the motor to turn faster, then I have to increase the amount of magnetic force acting on those coils. And I do that by increasing the current. And I can increase the current by going to a higher voltage, or a higher voltage, or higher, or higher, or higher. And eventually I'm at about 15 volts here, and you can see that what's happening is it's spinning quite rapidly. So the Genicon can act as a motor or a generator. Well, just a second though. If this Genicon can act as a motor or a generator, then this Genicon should be able to act as a motor or a generator. Which means I can use one of these as a generator to supply electrical energy to the second one, which should behave like a motor. So I'm going to connect these 2 together. And I will crank one of them. And you will see that the other turns in response. In fact, this is a very crude explanation of how a microphone causes a speaker to produce sound. When you speak into a microphone, there's a little tiny magnet in there that vibrates back and forth to the pattern of your voice. And what happens is that sends an electrical signal through wires to the speaker, where there's another magnet. Now the speaker's amplified, but the other magnet ends up moving in response, pushing air out of the speaker, and we call that air moving around sound.